So this is we are talking about the introduction to the brief history of the SCADA. SCADA system means we use a sensor to sense the operation of the machinery. Then we feed to the data into the computer, and we make this a control program in the computer. Then this computer commands are interpreted, and then the performance stage are execute, and the commands is sent back to the sensor and then go to the process. So this is the basic outline principle of the SCADA system. Therefore, this SCADA systems we include the server sensor, also the PLC, programming logic controller, and then those are controlled by the main computer system. So therefore, the main computer system control the data control devices, data control system DCS, or the programming logic controller. Those are connected to the sensor. Therefore, the output states are fed to the programming logic controller. They are also monitored by the main computer system. This is the overview layout of the programming logic controller and the data system, SCADA system. Therefore, this SCADA system includes all the data inclusion, so the data acquisition, and also we provide the computer is connected to the supervisory control, and then this controller is connected to the other network computer by using the Ethernet system. So this is the communication and the control layout of the SCADA system. Therefore, this SCADA system includes the software. This SCADA software uses this is a SCADA software system. SCADA software system uses the input-output P sensor, also the display, also the instrumentation, also the computer. So main computer system connected to the instrumentation, connected to the display, also connected to the data control devices, and also the input-output devices. Those are connected to the SCADA system. So this is the SCADA system, or data control systems. We use a multi-core cable or a single core cable. These cables are utilized, so their installations are you prevent absorbing any interference. Any interference signal need to be eliminated by the protection layer. So this is the data control cable. So those data control cables are utilized in the programming logic controller and the SCADA system wiring. So this SCADA system included here client server network. So this server network, client server network is if the clients states request any operation, so that the main server system provide the appropriate software system to operate the desktop computer, client computer. So that the SCADA system also utilizes modulator and demodulator. So this is and these are analog system need to be converted to the digital. Also that their data interface system, we use a modulator system, more modern utilized in the computer. So this is that this computer can be connected to the network by using the modem. So this is a control system, central site and a master station. So this master station we use here power supply. Power supply the electrical power connected to the individual PC unit. Power connected unit, after we use a bridge unit, also the radio transmitter, then we transmit the signal, those signals are received from the line, and then we execute, and then we fed to the main computer system. This is the layout of the transmitter and the receiver system, control system. So this is the central site of the master switch here. This is the RTU slave address. So those address are we provide the appropriate signal to the load address and then execute the operations. So this is for the panel of the SCADA system, front panel and the back panel of the SCADA system. So you can see the data layout and the control block diagram of the SCADA system. So this we use as a hardware, software, and a firmware. So SCADA system is a supervisory control and data acquisition system. Meaning that its systems are consistent in number of remote terminal unit, RTU, and it's collecting the free data connected back to the master station via the communication system. The master station displays the acquired data and also allows the operator to perform a remote control tasks. Therefore, this SCADA system includes the remote control terminal. Those remote control terminal collect the free data. Then those data are connected to the master station. through the communication system. The master station display the acquired data and also they allow the operator to perform the remote control tasks. This is the function of the SCADA system. So the different function of SCADA system include the here will be the modem, remote control unit, and also you use the programming logic controller, operator station, radio modem. So this is the programming logic controller connected to the modem and the operator control panel and connected to the modem and also remote control terminal. So this is the overview of the computer control system, SCADA system. So this means the mainframe computer is in mainframe. This is the heart of the operation. So this mainframe computer system is a operate as a main data processing, and then also include a master station. Those master station is connected to the individual computer system. So though master station also we use a sub master station. Some stations are also main station control connected to the sub station. Then sub stations are supervising the operation of the individuals remote control unit. So this is where the outline of the SCADA overview system. So this is the distributed control system. So this is distributed control system. Main power line, mains are the main line, control line, and connected to the individual unit. And so this unit are performing the alarming trending, the server function, also the remote control terminal. So they send the data from the real process operation. So those data are received from the real process operation. The sensor set, and they send the data to the major bus bar. The main bus bar is distributed data to the control terminal. So those control terminal control the appropriate operation. So this is a PLC station 1, PLC station 2, PLC station 3. Those are PLC connection are connected by the data control line. Smart instrument include the programming terminal, also we use the programming logic controller terminal, also the smart instrument. This smart instrument include the analog quantity will be sent, and then digital to the analog converter also included, and also the digital bars are operated. So this digital to the analog to digital converter is a transfer, and then they will send the data to the main system. So this is what the overview of the smart controller instrument. So the SCADA system we have to when before you install the SCADA system, you need to assess the overall controls requirement or the sequence of the logic, analog loop control, radio, number of the analog to the digital point, field speed to control and the data acquisition, master operator control system, type of the display required, historical archiving requirement, system configuration, reliability and availability, speed of the communication, update guide system, scan rates, and system redundancy, especially capability and application software and the modeling. So those things have to be considered to install the SCADA system. So therefore, this SCADA system also we utilize the radio antenna system. In this case, we use the power supply central processing unit, volatile memory, non-volatile memory, analog input module, server analog output module, digital input, digital output module, then connected to the central bus, then connected to the modem, and then we use a radio transmitter, and we use the antenna and send the signal. In this case, we also connected to the serious connected port. So we are connected to the odd signal and also the operator system, the operation and control system, PLC system. Those are included in the operator control panel. There's also the control processor and the associated memory include analog input, analog output, counter input, digital output. Those are also communication interface, power supply, RTU. Those are included. So in this case, they are CPUs they are operation function, EEPROMs are operation, IM operation, electrically erasable memory, EFPROMs are operation. So there are how many bytes are required to operate. They are also included. This is the ways you can know about the CPU, their data byte. So in this case, we also have to utilize the RS232, IF2, IF485 data. The data this system, they both are need to be utilized. Those are utilized to interface to the diagnostic the terminal, interface operator station, and communication link to central side. They are also included. Also, the analog input module we use the input multiplexer, input signal amplifier, sample whole circuit, analog to digital converter, and the interface and boarding timing system. Those are the analog input modules are also included. Those input modules are also included. This is for the typical block diagram of the analog input module. They use the data multiplexer, also use the analog and digital converter system, and provide the logic controller, also the transmission system, also data clouding system. Those are included in the input module. So we had to use a multiplexer to say that all the parameter of multiplexers are into a crosstalk, input leakage current, setting point, and switching type, and true out array, and then transfer accuracy. Those are also included. We also utilize the amplifier to amplify the signal. Sample and full RNA also analog to digital converter system. Those are also you can read in the data. Those are the most are the exactly. And here is a typical input circuit input diagram. So how the external signals are received and connected to the cable. And so the input converter connector also includes input amplifier system. So this is the signals are received the signal. Also we use an input multiplexer also include. Also we use the input amplifier system. This is for the layout of the input system. So this layout of the input system this is the conventional layout of the input system. So this input system is connected to the input module, and several modules are connected like this. And also that we also use the digital input. Digital inputs are interface system, optical system station, and then we convert the signal, and also we use the input digital signal system. So this will be the typical input signal modules are also you see in this diagram. Also, we also use the bus inputs module. All the bus inputs are have to go connected, so that all the bus input coming here, and we use the obligated isolation. So bus inputs are accumulator system also included. So bus inputs are buffer register also included, and also the address and data bus are included. So this is for the bus inputs module system is also you see in this diagram. So we also use as a counter. We also when we are using it, we also sometimes we also use a counter. In this case, we use as a full counter input, 15-bit counter frequency up to 20 kilohertz rate, and a duty cycle. Those are the counters are also utilized. Also, digital output module are included trial switching, relay switching, and a TTL voltage input. This is the digital output module. So this is the connection diagram of the digital output module. We see the interface to the talent backing or the laser driver system. Also included the digital outputs as several lines. So this is the typical digital data outputs module system over this connection diagram. You can see it. So that we use the digital output connected to the source, and so the digital individual digital output channels are connected. So they are connected to the connected to the digital output modules connection diagram, and then power supply diagram you also see in this diagram. So in this case, sometimes we also utilize the mixed analog and digital module are also utilized. Also that we use a communication interface. So we use a RS232, RS442, RS480, right? Those are the database system interface system we utilize. Also utilize a microwave or satellite system. HR25 is a packet protocol. Those systems also radios are transmitted frequency system we use. We use also power supplies module for the RDA also utilized. So the RDUs are conventional enclosure. We need to test this test and maintain this manufacturers maintenance system also utilized. This is the testing and maintenance system. So typical requirement for the RDU system is we have to write the appropriate hardware systems we utilize. Now this is appropriate hardware. Hardware are the hardware utilized in the RDU system. Remote transfer unit system. We also utilize the RDK. Those are the requirement for the RDU system. So also we also need to put the environmental consideration. Also that we use applications program. So in this case, appropriation programs are we use for the analog and load control or the meter or the flow measurement, and they also use so the PLC we use for the remote control devices system. Remotes are transmitting the unit. So those are the RDUs we use a PLC. Programmable logic controller is a computer-based solid state device that controls the industrial equipment and process. It was initially designed to perform the logic function executed by the release, drum and the switch, and the mechanical timer counter. Analog control is also the standard part of the PLC operation. The advantage of PLC over the RDUs offered in the radio manufacturer is that it can be used in the ground general purpose role and can easily set up the various different function. This means that instead we use a programming logic controller, use it to the remote controller station. So this is the we use a PLC at the special remote control station. Therefore, they can be connected to the main system as well as the individual control can be provided. So that we use a PLC software here. This is the PLC software. So this is the function of the PLC chassis and the PLC software installation we can see. We use a ladder logic diagram. This is the ladder logic diagram for the PLC. So I have already explained you about the PLC ladder logic diagram. We also use the logic. We use the PLC operation or the timer counter, arithmetic logic, and more comparison, file manipulation, sequence instruction, communication, diagnosis. So those are different kinds of the PLC logic construction. So these are PLC logic switch performance, and they are PLC logic output inputs function. The chart diagram is also you see. So this is the input output function chart, the input output switch, and also there are input output timer system, also input switch. When those switches are operated, and how the output function will be coming out. So it can be you can see on the graph. So this is the typical connection diagram of the PLC and the PLC system and the input output stations arrangement system. So this is what we use a radio transmitter system, operator logging system, local area network, gateway, and PLC. So this is the arrangement of the PLC system. So this is what the typical hand drive for the CAD system. So this PLC we also utilize the protocol and also the computerized. We use the computer aided design system or computer aided manufacturing system. That systems software are installed. So that software is programmed and then operators are operation of the PLC and the SCADA system. So here we see the typical log control diagram of the connector system. So this is for the typical token ring system. This is sometimes we also utilize the operation node in the ring system. So this is the token ring network. And also this is for the token plus network. So network configuration is we utilize for the PLC control system. So here you see there's a solid SCADA system control system. You can see the CPUs system, CPU are primary. Also the video display printer also connected. Also manual switch. We use the communication system, modem, and the radio. So this is what the SCADA system, code standby SCADA system you can see in this one. Here will be the dual ports system. So this SCADA system also you can see there are two ports can make the operation in parallel. So communication architecture is this is master system and connected to the switch. Port to ports are two station system. RTU is also utilized. Also we use the token ring system also as well. So this is a typical ring system. Also, we use a master slave network. Master slave network also utilized. So this is servers RTU are connected, and there's a ring and a master slave network is also utilized. So this means that voltage and then when we utilize the system, this was the timing, voltage and current relationship. When the PLC operation, you can see in this diagram. So this is a master station. Master station are included the hardware, handshaking, station address, protocol message, RTS delay component of the master staging system. So we use as a component of the SCADA system. This is a typical arrangement of the SCADA system. So this is a typical arrangement of the SCADA system. So SCADA software diagram is utilized. This is the display server, also the data line printer. Also we use the analog control devices. They are connected to the SCADA system. So this SCADA system interface are user interface. Keyboard, mouse, trackball, touchscreen are the SCADA user interface. Graphic display, you also utilize the graphic display system. Also we utilize the software alarm system. So they are SCADA component. Also train is how the train architecture, how to design, how to connect it, how to play the display. Those things also are also included. So also the RTU and the PLC interface system also utilized. In this case, we use the appropriate protocol, also the driver toolkit, also interface system, optimization system, scalability, access with data systems are protocol. Also that we also use the database system. We also utilize the appropriate networking standard for the SCADA system. Also the fault tolerance and redundancies are scheduled. Client server distributed processing. Those are also included in the SCADA component. SCADA software also utilized. The SCADA software are we utilize as a central computer system. We install with the SCADA software system. Then they are connected to the terminal, also connected to the programming logic and controllers terminal. So the SCADA system control the operation of the DSC. In the meantime, this main terminal connected to the server terminal. Main processor is connected to the server terminal, and those terminal control the appropriate PLC system. So this is the centralized processing system. This centralized processing here is the distributed processing. Individual system units can control the individual PLC. So here we use all the connected to the all SCADA system line connected to the appropriate train and repo and alarm system, and also utilize the display connection like this. So this is the server lines are connected. Last system have the server line local area network, also mainframe computer control system, IO input output server system, and connected to the appropriate PLC system also utilized. So this will be the data bus bar and the display unit and the PLC unit are also connected. Or here is the two-line system, line 1, line 2 system. This is the only single line local area network. This is two local area networks are connected in parallel and connected to a server display units like this. The system response time also included. Expansibility of the system also included, and the specialized SCADA protocol. Instruction to the protocol also need to be utilized. Here is the instruction to the protocol. How many data bits will be utilized? Database arrangement. In the information in the message, how much data bits are included to operate the function code or RDO address code or security code. They are feature of this database. So that any address are into the appropriate bit allocated to the perform the RDO address or the function code, security code, and then the main message base you are also seeing in this system. So the information transfer is also utilized. Those are the information transfer. Firstly, we use a master remote. So in this case, function code included. Central control select the message. So the control address need to be utilized. And also we set the byte. And remote to the master is we also utilize the function code and also check back the message. And in this case, we have to check the control address and the set byte. Master to remote, in this case, include the function code and then execute the message, include the control address. Remote to master is a function code included, execute the acknowledge and the message. So this is controls address. So this is how the master to control instruction provided. So how the which kind of these codes are included, what kind of the address are included in the message. So this is the sequence of the message for the control system. So that this is the sequence of message control system. So this is for the test data transfer system. This includes test data transfer system, code, also remote to the master data transfer system. This was the arrangement of the code system. So we also utilize a 12 are analog value and 128 are status base or 24 status with the memory and all combination of analog value and there's a values and the status base are also included. Also, we also utilize the high level data link control HLDC control. In this case, high data link control system include the unbalanced normal response mode. This is used with the only one primary or the master station, initiating the order transaction. And synchronous balance mode as the ABN is this modes each node is equal status and again as another secondary or primary node. Also, we use also the frame format. So this is the frame format, the status frame that define delimiter and our frames are header include the flag address and control information create this information and frame check sequence and end of the frame delimiter. So in this case, finally you enable the flag. So information include the number of bits arrangement and super bits bits arrangement. So this is about the how there's a control and the information super bits how many bits are arranged. You can see in this one. Also the receiver ready, also receivers are not ready, reject or selected reject, those functions also included, and means a normal response, sets as synchronous balance mode, disconnect, another acknowledgement, another bow, and frame eject, etc. Those are also included in the frame format and the dice. The content of the frame also included flag character, also included the flag character. This is this for all the flag character. Also, the mainframe chat sequence also utilized. We have to check the mainframe chat sequence. Also, it includes the address fee or the scanners are secondary address also include. We also include the group address for the group node for the network and the broker address also include. This is for the contents in the frame are the those are first are content in the frame. Protocol operation also include the multi-user drawing is the primary node send the normal response mode. Frame with the PF bit set to 1 and with the address of the secondary. So the secondary response with the unbound acknowledgement with the PF bit set to 1. Alternatively, the receiving mode is unable to accept the setup command and this connected mode frame is redundant. Data is then transferred to the transmission frame. The primary node then are sent unbound frame containing this context in the control fee and the secondary then respond with the unbound acknowledgement. So this is the protocol operation of the PLC SCADA control system. Also that we also utilize the error control and flow control system also included. This is the error control system. Also CSMA CD protocol format also utilize. This is a CD protocol format. So this is the component of the CSMA CD protocol format. In this case, you can see that this explanation. What is a standard activity? Mean that 3 is a definition provide a definition of many data communication and style time. 4 is a functional characteristic provide a typical equipment configuration and a functional application. 4 are the communications are provided interface characteristic. Master remotes are communication interface and channel loading calculation. 742 is the communication security provide the performance requirement of the error control. Those are the typical SCADA standard system. SCADA system across the ASRS, IEEE's C37Y1987 standard. Those are the appropriate number and their meanings. Also, this is the appropriate number and their meaning also applied. Also, we need to detect the error, their detection. So there are detections because of the attenuation or the limited bandwidth or delay distortion and noise. It can cause the data. So in this case, we also have to explain about the how the data attenuation happen, how the limit bandwidth happen, how the delay distortion happen. And also we have to find the appropriate data bit calculation diagram or the feedback control sickness diagram. Also, we also need to find out the redundancy check. Also need to be utilized and also block redundancy separability data check also you include. So here is the transmitters message including also the receiver message. The transmitter is we send this message and receiver is this message. In this case, how the error can be detected, you can see the error detection method. Also, the arithmetic checking sum is also utilized. How many that we send all day and how many receive. So in this is how many data can happen can be checked like this. So this is the Those are data checking are provided by the data checkers equipment. So the distributed network protocol is the distributed network protocol is data acquisition protocol used mostly in the electrical and utilities industry. It is designed as an open, interoperable, and a simple protocols, especially for the SCADA control system. It uses master-slave pooling the methods to send and receive the information, but also implies a submaster within the same system. The physical layer is generally designed around the RS-232, but it also supports the other standard protocols such as the RS-422, RS-485, and the events are fiber optics. There is a lot support within the SCADA industry to use the DMB as a universal different to standards and data acquisition control. This is what the distributed networks protocol. So this is a IEE's standard and SCADA system distributed network protocol system. This is the distributed network protocol master and slave network. Here is a master slave and two slave network connected and two wire point to point control here master slave and for direct connected system. Also we utilize a modem and tools are wires are multi-drop modem. So this is master slave system, multi-drop modem. Here is a 4-wire point-to-point control system. Here is a 4-wire serial mode control system master slave network. Here is a data modem, tire modem system, devices PLPC, public switch telephone devices are connection. Also the frame outline, the outline of the frame. Also this is the DMB's pockets format. You can also see it. Also function code. The function code set, reset, test, user data, unconfirmed user data, request status. Also the when you send the data here, this is confirm. This is for the send and the receive. Reset of this secondary link diagram. Also you can also see it. So this is the station B. How you send the data, how you confirm what kind of the data will be included. Also you can also see it. So no reply system is the data format here. So this is for the request response system. This is request and response, positive response, negative response system. Also we use the transport layer control. So the application layer, transport layer control is a application layer. Transport layer is the distributed network protocol does not support the true transport layer as defined by the ISO, the open system interconnection model. It does not support the bus user, transport layer known as a super data link protocol. So the application layer is a support the application layer by defining the existing data, object library, function code, and a message format. So this is application layer. So the application layer is define the data. Also we utilize library. Also we utilize a final application system like this. Also the remote terminal units are also included. Remote terminal units are the how the terminal unit does decentralized processing unit also utilize. Also we utilize communication system, open standard, spectrum, satellite system, fiber optics. Those are the appropriate communication system between the remote terminal unit. There are the 12 golden rules. We have to utilize the SCADA system. Firstly, we utilize the KISS principle. Ensure the implementation of SCADA system is simple. Ensure that the response time of the total system, including the future expansion within the current level, typically less than the 1 second operator response time. Evaluate and redundancy requirement. Carefully assess the impact of the failure of any component of the system on the total system. Apply the open system approach to the hardware, selected in the protocols, communication, standard implemented, confirm that these are the indices of the truths are open standard. Ensure that the whole system, including the individual component, provide the SCADAlesson architecture, which is expand with the increasing system requirement. Assess the total system from the point of view of the maximum traffic loading on the RTU, communication links and the master stations, and the subsequent impact on the hardware, firmware, and the software subsystem. Ensure that the functional specification for the system is clearly defined as far as the number of bytes are concerned, response rates, and the functionality required of the system. Those are the included are important of the perform the through the testing of the system, confirm the operator individual component of the system, ensure that the configuration and testing activities, and finally The implementation is there is a supervisory system do not override with the operator. So those are the important aspects to the to do the SCADA system. Important we have to apply the approach case principle. Also we have to concern with the evaluation time, also redundancy requirement. Also the whole system component need to be there's appropriate architecture, and also we have to ensure the functional specification. Also we had to do that throughout testing and operators functionality. Those things has to be concerned on the SCADA system. So that this today's lesson is I give you that overviews a meaning of the SCADA system, over the operation, over the layout, also their connection and the protocol for the SCADA system, software, hardware requirement, and communications protocol, also the data system for the SCADA system.